Okay, here we are. Super exciting. Domain and range. So domain goes on what axis? X, the x-axis. So our domain goes on the x-axis. And therefore, our range goes on the y-axis. So when I'm talking x-axis, I'm talking left to right. And when I'm talking y-axis, I'm talking up, down. Right? Yes? And we'll get to the vertical line test a little bit later. Okay, so to raise a flag, Peggy pulls. So this is like taking your 5.4, where we were interpreting graphs, and putting it on a graph. So Peggy pulls a rope to steadily is the key word, with both hands for a short time, and then moves both hands up the rope and pulls again. She does this until the flag has been raised, which presents the height of the flag. Justify your choice. So we have 4 graphs there. Which one demonstrates this scenario right here? So which graph? Good 5.4. This is going to be on your quiz on Monday. What graph would match that scenario? So puts hands over hands, pulls, goes up, pulls, hand over hand, pulls the rope down. Rahat?
I think it would be graph number C.
Graph number C, okay.
Because she at first she does it steadily.
Yeah.
And then she moves both hands up the rope. So with time in the beginning, we actually know it would be graph A.
Okay. Anybody else have a thought or opinion? I got to vote for graph A. Do I have any other ones? No? We all just agree with graph A and we're going to move on, or you guys are emotionally not ready to discuss?
I don't understand what they say.
Watch. I need to pull the rope, like I'm pulling the rope down so the flag goes up, right? So I put my hand over hand, I pull. Hand over hand, and I pull. My hand over hand, and I pull the rope. B. Because you have that steady pull right there, but then we have a period of time. What's happening? We just kind of pause, because what do I got to do at that time? I'm readjusting my hands at that point, right? So I have that steady pull, and then I have a pause where I'm readjusting my hands. So that's your steady pull right there. And then these flat pieces are when I'm moving my hands. Move hands. And that's the steady pull. And I do that until the flag is at the top of the mast. And other people might do it a different way. They might just do it hand, pull, over hand, so there's no pause. But this one is hand over hand, and then the rope pulls again. So there's that pause in between. Okay, okay, that was just 5.4 review, because I know you're excited about it. Okay, determining domain and range. Domain and range of discrete data. Do you guys remember what discrete data was? Rahat, what's discrete data?
Discrete data is something that is like, we have increments, we have an x-axis and a y-axis, and everything is to scale.
That's for most graphs, right? So that's a good description of graphs. But what about discrete data? It was the cans of soup. What couldn't we have? That was discrete data on our last assignment. You couldn't take half of it, right? You couldn't have a portion of it, because nobody wants to buy a half can of soup. Who knows what's in it? So discrete data, and so that's, we don't connect the points because we can't have points in between, are written as a list, and you guys have done this before, using set notation. Now that's the math word, that's the mathy word for fancy brackets. Okay, so set notation is the mathy word for fancy brackets. So domain and range of continuous data are connected. Okay, so continuous data means that we can have parts. So that was like the temperature graphs that we did, the temperature, the time, the age, those sort of things. They can be listed in two things. They can be set notation, so that's the fancy brackets, or interval notation, which has square and round brackets. Okay, all right, in interval notation, square brackets mean the number is included in the solution, and a round bracket means the number is not included in the solution. Okay, when using set notation for continuous data, you put the variable in between, you put your minimum value, so your lower limit always goes on the left. So I like to say lower on left. So the lower value, the lowest value you have, goes on the left-hand side. Okay? And all the arrows point in the same direction. This is kind of a messy one. Okay, I'll get to that in a second. Okay, that's the good luck with that. That's all the rules, but we don't really get to it until we practice it. Like, it doesn't really sink in. I will tell you that most people like interval better than set, and I think it's because we don't practice our fancy brackets enough. Okay, so we're gonna run through this. Independent and dependent variables. Independent and dependent variables, and we're gonna justify our choices. You're gonna tell me why. So which variable is my independent and which one's my dependent? So let's talk about the variables. What's happening on the x-axis? Time. Time's happening here, right? Time's happening on the x-axis, so this is one variable. And it's probably the letter T in the equation if we were to create an equation. And the number of boats. So that is my second variable. Sorry, you couldn't see that. I just wrote second variable there. Okay, so this is the number of fishing boats anchored in an inlet. So the time of day versus the number of boats. So which one is independent? The time. I would agree. So my independent and why is it time? Okay, yeah, for sure. But it's the time of day that affects or has influence on the number of boats in the harbor. Or inlet, sorry, we're in an inlet, not a harbor. I don't like the start of that sentence. I'm going to switch it around. The number of boats depends on the time of day, which makes sense. So really, really early in the morning, before anybody's woken up, are there lots of boats or are there no boats? Nobody's woken up yet. There's lots of boats. Okay, so like if we think of Paint Lake Marina, hopefully we've all been to Paint Lake. If you're there really, really early in the morning, most boats are still in their dock space, right? The place is filled with boats. But what happens in the later afternoon? People start waking up, they decide they want to go to their cabins, they want to go fishing. So as the day goes on, what happens? The boats go out on the water, so they're not in the marina anymore. And then guess what happens around supper time? The boats come back. Make sense? Okay, why are the points not connected on the graph? For what? right? But which variable can only have whole values? Because I can have a half an hour, but can I have a half a boat? So my boats, can I have half a boat? Chances are it'll be on the bottom of the lake or ocean if I have half a boat, right? So that's why we have discrete data. Although we can have parts of the time here, we can't have parts of boats. We shouldn't. It's bad. All right, so now we're going to determine the range and the domain and range for this graph. This is easy. You guys have done this before. It's super easy because you've done the list before. You've done the discrete data before. That's what we've practiced before. So we're going to start with D : for the domain. If it's discrete data, we have to use fancy brackets. There's no other option. So we're going to use our fancy bracket. Oh, that's a terrible fancy bracket. All right. So what is on the domain? Domain is, you guys told me my independent was time. So my domain is time. All right. So let's start at our earliest time. What's our earliest time? 9 a.m. What's our next time? No, we got a dot here. We have dots in between. So 10, 11, 12, 13. Okay, so each one goes up by 1. So then we have one at 10 a.m. And we have the next one at 11 a.m. And we have the next one at 12 p.m. And the next one after that is 13 o'clock. Whew, we're using the 24-hour clock. How do you like that? And then the next one would be at 14 o'clock. That was that one. 15. And the last one is 16. And I'm going to close my fancy brackets. Okay, knowing your domain, is this a function? It's either no or yes. 50-50 chance. It is a function. Because there's no repeating domain values. All right, let's go to range now. So I'm going to start this with an R and then a colon and then my fancy brackets. And range is the number of boats. So now we're looking at our y-axis here. Might switch to a different color just so I can point at them. Okay, so we want to do our list in ascending order. So where are we going to start? What's the lowest number? Ascending starts from low to high. 6, I think. Because these go up by 2s, right? So we have 2 values here at 6. Do I need to write 6 twice? No, I do not. All right, so I got rid of those ones. What's next? What number is next? 8, because that's that one right there. So that's 8 boats in the harbor. Do you guys remember Sesame Street, the count? Of course. Okay, I'm just making sure. I'm old and I don't know if my references are any good anymore. Okay, the next one. I got 2 at the next one. What's the next one? 10. So when we're looking at the range, we're looking at the values along the y-axis. And then I have this one over here, which is at, it's halfway in between 10 and 12. 11. And then I have this one. So it's halfway in between 14 and 16. 15. And then my last one is way up here. And how many boats is that? All right. Hopefully it's 25. So that one, we've done lots of that, like right in 5.1, we did the list, like what was in set 1 and what was in set 2. So same sort of thing, but now we have to give them very special names, the domain and the range. Okay, now we're gonna get continuous. So you guys all know that this is discrete data. Let's just write that up at the top. And we know it's discrete data because the points are not connected. Okay, now we're going to go to our continuous data. So that one's continuous because our points are all connected. So both of these examples are continuous data. Okay, so here's the thing. Sometimes our graphing programs can be a little bit finicky. They don't do it the way I'd like to see it. I want to look at this graph just for a second. If your graph, see how this end goes right to the top of the graph? You can assume that that continues on. Now, normally we just put an arrow on it, and that would indicate that it continues on. But because this graphing program doesn't have the ability to put arrows on it, it just shows it going right up to the top of the screen. It's like it shoots off the top of the screen. It's a little bit of a pain in the butt. Now this side, does this side keep going? Does that side go right up to the top? No. So this means it stops here. Okay. All right. That's kind of important because you're going to see a bunch of different graphs. So let's go back to this first graph here. Does this graph stop at these points or does it keep going on? It stops, right? And I know this seems obvious, but I'm going to keep repeating it because I know even like when in my grade 12 class, we had questions about this because I was using this graphing program and it didn't have arrows and they were a little bit confused. Because arrows always mean like, hey, I'm going to go on forever. Okay, let's talk about, so which one is my domain? Is it my X or is it my Y? You have no context here. Like it's not boats in a harbor or time of day or weight of soup cans or whatever. Right?
Your domain will always be the X.
Right. So if you have no context, you know that the X will be your domain and your range will be your Y. Okay, and what I mean by context is like you don't know what the graph is kind of measuring. Okay, we're gonna do set notation. So this is fancy brackets. I'm gonna show you both ways. But we're going to start with fancy brackets. We're going to start with the set notation. So this is option 1. This is option 1. Okay, so we got to do our domain. Fancy bracket. Okay, what is the furthest left we go on this graph? What's the furthest left we go? What's the furthest value we get to? What's the lowest value we get to on the left? -2. So this is my minimum domain value. Is that -2? Does that make sense? Yes? So we always put the lowest number, the lower limit, the minimum, on the left-hand side, so -2. Okay, that's exciting. What's my highest value I go to? I think somebody said it. What's the highest value I go to on this x-axis here? 2. So I'm going to leave myself some space and I'm going to put a 2 there. And then I'm going to put a fancy bracket around it. Okay, so we're on the domain. So what letter goes with the domain? What axis is it on? What axes are we on here? The x-axis. So if we're dealing with domain, we're dealing with the x's, so x goes in between it. All right? So your arrows always point in the same directions. Now, it includes the point -2, and it includes the point +2. So we're going to say x has to be greater than or equal to, like if we just read that side, that says x has to be greater than or equal to -2. And on this side, if we read this side, it's x has to be less than or equal to 2. So we write it as one statement. This is set notation for continuous data. Okay, let's do the range.
What is x?
What do you mean, what is x? What axes are you on when we're talking about domain? Okay, so fancy brackets again. So how low does this graph go? What's the lowest y value? How low does it go? 0, right? Because the graph doesn't pass 0 on the y-axis. So the lowest it goes is 0. All right, what's the highest it goes? How far does this graph go? 2. So that's my highest. So the low goes on the left. I'm going to close my fancy brackets just so I get my fancy brackets done and out of the way. What variable are we dealing with the range? The y. So the y goes in between, and all your arrows point towards the left. Now that's not a point on the graph. I've just labeled it because what's the y value here? That's on 0, right? This value, this point would be 2, 0. Right? That point right there would be 2, 0. So that's my y value is always my second one. Okay, so I'm going to teach you how to do it with interval notation now. So let me write that out. Interval notation. And these are your square and round brackets. I write really crooked is what I realized about myself. Okay, domain, what's my lower limit? You already figured it out. What's my lower limit? You told me already. -2, right? So -2. Does it include the point -2? Yes, it does. So because it includes it, I use a square bracket. All right, what's my highest limit on the domain? It's +2. Does it include +2? Yes, it does. So square brackets means that it includes this number. Okay, so when I use a square bracket, that's what it means. Okay, so range, what's my lower limit? You guys already found it. The numbers don't change, we're just displaying them in a different way. So it's 0, and it includes 0, so it's a square bracket. The range, the high value is 2, it includes it, so it's a square bracket. Okay, all right. Proud of you guys. Okay, this is the tough stuff, and people still struggle with this, but we do a lot with domain and range. Like, especially if you're going into the pre-cal stream, we do a lot with domain and range. Okay, let's look at that second graph. Okay, so we're going to do option 1 first. We're going to do set notation. I'm going to do set notation first. We know set notation is our fancy brackets. So we're going to do a domain first. Open our, oh, that's a really bad fancy bracket. But you get the idea. It's fancy. Okay, how far do we go left on this graph? What's happening here with this arrow? It means that it's going to continue on, right? Everybody agree with that? So is this not going to go on for ever and ever and ever? And in math, what do we call counting forever and ever and ever? Where are we going?
Irrational?
Nope. What's way over there that we're never going to get to?
Infinity?
Infinity. But if we're on the left-hand side, what kind of infinity is it going to be? It's going to be a negative infinity, right? Because we're in the negative numbers over here. So this is going to be a negative infinity. What is the highest? How far right do we go in the domain? How far right do we go? Three. Because if we look at this point occurs at 3, 8. That's that point right there. So that's 3, 8. So the farthest right we go, because it stops there, it goes to 3. Okay, we're dealing with our domain, so what variable is that? It's not going to change ever. X. Now, does it include infinity? If I asked you to count to infinity, could you do it? No, because it's an idea, like it's a concept, it's not an actual number. So it can't include infinity, because if I asked you to count to infinity, you'll die, I'll die, it'll be a bad day because we'll all be sitting here waiting for you to finish, and chances are we'll pass away before that. So we're not going to include it, so we're not going to have the equal to sign there.
Yeah, I don't think there's actually infinity.
Well, infinity is a concept, so
How do you know if it even exists anymore?
it doesn't, because it's a concept, it's an idea. It's like you're not trying to get to infinity. Infinity isn't a destination. It's that it can go on forever. So it's the idea of going on forever. But on the right-hand side, I'm going to 3. Do I get to 3? Do I include 3? The answer is yes, I include 3. So this time, although my arrow still points here, I put the equal to sign in with it. So one side has it and one side doesn't have it. Okay, let's talk range. Fancy bracket. All right, how low do we go on this graph? What's our lowest number? Where on the y-axis, how low do we go? -1. Good job. Now, how high do we go? Now, on this side, we stop at 8, but what's this arrow doing? It's going to continue on forever, but we're going up to infinity this time. So what kind of infinity is it? It's positive infinity. Close my bracket. What value or what variable is associated with the range? Doesn't change, guys. The y. Range is y. So we have to put the letter y in between. Now, do I include -1? Do I hit -1 here? Yes, the graph includes it, so I put the equal to sign. Does it include infinity? Can I get to infinity? No, I cannot. So I put my arrow, but I do not put my equal to sign. Okay. So now we're going to do interval notation. And I'm going to go a little bit faster. And if you guys can yell at me if you have any questions, that would be delightful. So domain, my lower limit is -infinity. My upper limit is 3. Now you guys told me that I include the 0.3, so I'm going to use a square bracket. But we do not include infinity. So if we don't include infinity, we use a round bracket. So when you do your brackets, they have to be significantly different. Like your round one has to look different than your square one. You know what I'm laying down here? Some of us are a little bit messy when we put our brackets together. They have to be different because they mean different things. So range for this one, we included -1, but we go to positive infinity. So this is a round bracket. So if I'm using a round bracket, does not include this number. So round brackets mean it doesn't include, square brackets mean it does include. Whew. Do you guys think you can do this? Okay, all right. Way to have faith, Jonah. Way to have faith. I think Jonah might have been joking. No, you think this is it? This is where your math career ends? Domain and range? Am I okay to flip this? Nobody's screaming no? Yeah. Perfect. Okay. Vertical line test. Vertical line test. Okay, I got to pick up my pace. I was a little slow on that one, but that's the most important one. So you guys know that it's a function if we have no repeating domain values, right? Okay. You know that when you do a table of values, but if you get to have the graph, if you can put a vertical line, you guys know what vertical line, vertical means up, down. Vertical is up, down. So when you have the graph of the function, if you have a spot on your graph anywhere, and you have to check multiple places, see how this one has, if I put a vertical line over this, does this hit the vertical line more than once? Yes, I have 3 dots on it. I have a dot here, a dot here, and a dot here. So we would say this fails. Okay, so if you fail the vertical line test, what that means is it is not a function. Okay, fails the vertical line test. So what you're going to see on graphs is values stacked on top of each other vertically. If you see that, you don't need to draw the line, but you can visually see that a vertical line would hit that graph more than once. So if it hits it more than once, which this one does, it hits it 3 times, it fails the vertical line test. If I look at this one, if I put a vertical line here, it passes. If I put a vertical line here, it passes, 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 passes. So if it only passes through it once, this one passes the vertical line test. So if it passes the vertical line test, It is a function. It is a function. So if you pass the vertical line test, so if you only hit it once, that means you pass the vertical line test. But you can't just do one vertical line. You got to do where it's obvious. Okay. Scroll this up. Which of these graphs represents a function? So is shoe size versus height? Does that one, is it a function? No. How come? The domain repeats, right? I fail the vertical line test here. I fail the vertical line test here. Well, there I'd pass and there I'd pass. So not a function. And when it asks you to justify your answer, that means give a reason. Why isn't it a function? Fails vertical line test. If only all tests were like that. You just have to draw a line and decide if you pass or fail. Okay, the second one, is it a function? Yes, it's a function. Yes, it is a function because it passes the vertical line test. If I were to put vertical lines all over this, I would only hit dots once. I wouldn't hit them multiple times. Okay, all right. Let's flip, we're very good. We're good to flip the page. Rahat's still frantically writing. You good, Rahat? Okay. All right, we got some new words. Steve, are you reading? Is that what that was? Okay. Interpolate and extrapolate are your new words. So to interpolate just means you estimate a value somewhere on the graph. Like you might not have data points for it and you have to kind of look at it and you got to make an estimation. We do this one a lot and I don't think we ever called it what it actually is. So we're going to interpolate. That means you're inside the graph. You're on the graph already. Extrapolate means the value lies outside of the graph, beyond the graph. Like you have to make an estimate like you're going off the graph. Okay? 2 new words. All right, determine the value when the domain has a value, I should say the value of the range, when the domain has a value of -2. So where's the domain? That's probably a good question. Domain is on my X or my Y? X. So what has this told me? This has told me that my domain is -2. So I'm going to go over to -2. And what am I going to do? I got to figure out my range value. So I'm going to go up to the line and I'm going to estimate. So what's the range at that point? Range. So remember, this is the scale of the range. So where does it hit? You're saying 15? 13. Might be a little bit below 13. Or do you think it's 13? Okay, I'm good with that. So the domain is -2, and we're saying my range is 13. Can we write that as a coordinate pair? What comes first in a coordinate pair, the x or the y? X. So as a coordinate pair, this would be -2 and 13. So what we're saying is this point right there on the graph is -2 and 13. So you're estimating, like it's not a perfect point. We just did this with boats in the harbor, right? That's pretty good. Determine the domain value when the range value is 4. So we know that our range value is on the y-axis. So we know we're trying to find the domain. Domain is question mark. And range is +4. So again, I'm going to do the same thing, but this time I'm going to be looking, okay, here I am at 4. I'm going to go over to the graph. I'm right here. And I'm going to go down. So what's the x value when y is 4? 1. So if I were to write that as a coordinate pair, it would be 1 and 4. So what did we do there? We were inside on both graphs. So did we interpolate or did we extrapolate? Interpolate, because we were on the graph. We were inside the graph. We were in the graph doing the math there. Okay. You guys are going to do the domain and range for the first graph, and I'm going to do it for the second one. Okay, before you jump into doing domain and range, before you start that, what's happening to the ends of the graph? If they hit the outside of the picture, what happens? They continue. So you can just draw arrows on them if that makes it easier for you to see that. And I'll do the same with mine. Okay, you can pick either set notation or you can pick interval notation. I'm good with either. So you guys are going to do the first one. You're going to do domain and range of the first one. Oh, geez, Louise. This is why I need to use erasable pens.
Thank you so much for working out so much.
You know what? Every day is just a joy. Except when I screw up my brackets. Jeez Louise. Fancy brackets. Oh, jeez. Are you guys ready for me to show you?
Yep.
Okay. Oh, hang on. Gotta add one more thing. I got liquid paper on my pen. Okay, that's what I got for my first graph. So I did both because I wasn't sure what one you were going to do it in. How many people chose set notation fancy brackets? Okay, all right. I like your commitment to fancy brackets. And then I'm assuming the rest of you chose interval notation. So interval notation, because I'm going on forever and ever, This means I'm going to get really, really wide on both ends. I'm going to get really wide to the negative and really wide to the positive. So I'm going to go to the negative infinity and positive infinity. And then same with my range. I'm going to go really, really low, and I'm going to go really, really high forever and ever. And I can't count to infinity, so I'm not going to include those points. So I use my round brackets. Again, if you did set notation, the thing I'm looking for is your arrows are all pointing towards the left and that they have no equal signs. So I'm going to tell you that you need to be able to read both, and you only need to be able to write in one. So I'm okay with whichever one you pick. What do you think the domain and range are for the next one? Exact same thing. Good call. Because the graph goes off in both directions, right? It doesn't have like one spot where it stops completely. Yeah, Rahat?
Say right now for the second one, both of these, the graph goes from left to right.
Doesn't matter.
Say if we go from right to left.
Doesn't matter.
But would the arrows change?
Nope.
So the arrows always go.
Always point to the left.
Point to the left.
Yeah.
Okay.
And that's it. That's a lot. Guys, I say like, yeah, that's it. But it is really a lot. And